Welcome back to the second part of Behavior Design walkthrough for complex distributed software systems. If you haven't watched the first part yet, click on the link at the top of this video to start there before continuing. Here's a quick recap before we continue today. In part 1 of Behavior Design, we worked with both the business and technical stakeholders to establish the business reality of the software system that we're building. We went through the first half of a workshop called Event Storming based on domain-driven design and established how the domain events, commands, actors, business policies, and external systems relate to each other and interact. From here on, we will focus more on the technical design with the software engineers. We will distill the business model that we've created to find out the inherent points of cohesion and coupling, where we could potentially break this system into multiple services. My name is Derick Chen, and this is Build with DC. We will continue with the event storming session. In the last session, we established the external systems with the business and technical stakeholders in the room. And the next part is the view model. But wait, before we go to the view model, we need to revisit exploring external systems from the engineering perspective as well. Apart from the business third-party integrations such as payment gateways, you may have external dependencies in purely technical processes of the software as well. For example, an email SMTP abstraction service provider, so instead of managing our own email servers, we just have to call an API instead. So remember to check on that with the software engineers. With that out of the way, let's move on to the view model. View model is how actors interact with the processes in order to issue commands that put domain events in action. You can think of it as an interface where the actors can interact with our system. Depending on the nature of the software system and the actor, the view model could be a mobile app screen, web page, or even just an API endpoint with specific parameters, if you are building an application for developers. This is the one component of event storming that is slightly less critical, but definitely good to have. Certain performance design tactics may require changes to the view model to optimize the end user experience. For example, when an action is changed from synchronous REST API calls to asynchronous driven events, the data loading sequence on the front end needs to be modified as well. So how much detail should we go into documenting the view model? For now, let's just stay at a high level, since we first want to have a comprehensive understanding of the business processes before we dive into the performance design. If you're building a new project, you may consider just writing down a placeholder for the view models for now. It may be just the name of the page that you intend to implement this at a later stage, since you don't have all the technical details right now. The next key idea we need to distill from the business model is the concept of aggregates from domain-driven design. From here on, the design becomes more opinionated, with the goal to establish a good service breakdown and distribution. We can dive deeper into the technical definitions according to DDD and discuss what are entities, value objects, and aggregates. But we'll do that in a future video that will be linked to the top of the video right here. Without going too much into the technical definitions, for our behavior design purpose, aggregates are the key concepts in our processes. It sounds simple, but it's not quite. There are sequences of domain events that are closely related to each other. For example, in the cafe, we have domain events like order placed, order confirmed, and order fulfilled. So these are related domain events revolving the whole concept of order. So order can be an aggregate in our domain. Similarly, the domain events related to payment can be grouped under the payment aggregate, since they are all modifying parts of the process that creates an irreversible change relating to payment. Identifying the correct aggregate is one of the most crucial steps in event storming workshop for the behavior design, because aggregates give hints of how we can draw boundaries around parts of the system that are closely related to each other. Aggregates show us which domain events are highly cohesive and should be implemented together. Once we have established the various aggregates in the business process that we're modeling, it's time to start thinking about how we can break this entire workflow into sections that can be implemented and deployed in parallel. This is particularly important for a complex software project where it's impossible for one team to single-handedly deliver the entire product. This is where bounded contexts come in. Bounded contexts are conceptual boundaries covering parts of our workflow where terms, rules, and concepts have consistent meaning within. For example, in the order context, a profile of a customer might have a history of previous orders and personal preferences. But once we cross into the payment context, the same term profile might refer to saved credit cards, available discounts, etc., while returning the same unique identifier for each customer. This is important for us to implement modules and services with specialized functionalities with minimal mutual dependency, both in the integration pattern and in the data. In our cafe, we can have 3 bounded contexts: order, payment, and fulfillment for now. But this is not the only way to break down the bounded context. In other philosophies of software design, it's also possible to align your distributed software units along different lines of business, user transaction journeys, or teams. But for a sustainable architecture, we need to focus on designing for future changes. We need to go back to the core principles of high cohesion and loose coupling. The best design will give us the highest possible degree of adaptability for future changes. Evaluate all these different bounded context proposals and see if we can shift the boundaries left or right in order to achieve a more cohesive and loosely coupled system. The key outcome that we want to have from this is that we want our software units to be independently deployable. Now, we have a proposal to break the workflow into independent services. The next question is how they will communicate with each other. But we won't go into the technical integration options yet. We will stay at a strategic level for behavior design and determine the relationship between services only. What kind of relationships, you ask? Well, we basically want to understand at the service level dependency at this point, how the upstream and downstream services collaborate. Broadly speaking, there are 3 types of relationships: collaboration, consumer-supplier, and separate ways. The nature of relationships between services will dictate how the technical integration implementation will be. For example, for a collaborative relationship, services may share a common library, and this is known as a shared kernel. While for the consumer-supplier type, it's more common to implement with an event-driven system, or REST API. We will spend more time discussing these tactics and trade-offs in the next phase of the design, performance design. And that's almost it for behavior design. Now you have everything you need for a service breakdown. Since we have already discussed the integration relationship between bounded contexts, does that mean that one bounded context should be implemented as one service? If you have watched my previous video on top of the screen right here, on the level of distribution for software architecture, you will know that that's not necessarily the case. It is possible to have small bounded contexts with minimal business complexity within that is highly cohesive and loosely coupled from the other services. If the complexity requires only 1 or 2 dedicated developers to implement and enhance, then you should consider deploying this together with another service. However, if there is a confirmed roadmap for major enhancements for this currently simple module, then it may justify being a separate microservice on its own. Remember, the ultimate goal of our design is adaptability. When making trade-offs, remember to evaluate which option will result in the most flexibility for future enhancements. These deliberations help us avoid an overly distributed architecture with high operational overhead. It is unlikely that the result of a behavior design will directly indicate that the best approach is a fully centralized architecture. In other words, a monolith. But I would not rule that out at this stage yet. For that, we need to evaluate the performance requirements in the next phase of performance design, understand our constraints, and explore the best way to implement and integrate our software system. In summary, we have now moved on to the technical perspectives of the behavior design and established a potential service breakdown for implementation. We follow the principles of high cohesion and loose coupling, using elements of DDD with increasing scope as guidance to decompose the business model. But it's not final yet. In the next part, we need to evaluate the performance requirement and what are the tactics we will use. You may discover additional complexity in the performance design, and you may need to rethink the service breakdown to achieve fast rates of iteration and adaptability for the software. We will discuss performance design in the next video, so don't forget to like, comment, and subscribe to the channel. My name is Derick Chen. Thanks for watching, and see you in the next video.